Hello, this section is entitled Networking, Deploy and Configure Network Load Balancer. And more broadly, this is really just exploring services in general and the various types of services. And load balancer is just one of them, actually. So in the last video, we essentially created what's called a cluster IP by not specifying a type. It defaults to a cluster IP type for a service, and that's essentially an internal load balancer. So that will basically load balance traffic across your pods, like we did an example of. In this case, we're using a service of type load balancer, which is essentially an external load balancer, meaning the website or whatever the service will be available outside of your Kubernetes cluster. And the key thing here is the load balancer is set up. It actually depends on your cloud provider to actually provide the load balancer, since it's external to Kubernetes. So, and every cloud provider will have a slightly different configuration of the load balancer. I mean, there's some core stuff, but there's some differences between cloud providers. Okay, so let's get started with, we're using Amazon, and we're going to do first just most simple load balancing with HTTP, not HTTPS. So we can look at the code for this, and that's in the templates. Let's see. We're going to do a load balancer with SSL after this. So this is just a load balancer without SSL. And the deployment is exactly the same as we saw in the last video, so I'm not going to spend any time on the deployment. It's basically just 3 instances of Apache web server. Now the load balancer itself is a service, and it's identical to other service, except for there's this one line. We added a type of load balancer, and that's it. So let's deploy that and see what we have here. So I'll do helm install dev load balancer. Let this install. Okay, and load balancer. Let's just see. It takes a minute to get kind of settled down, but I think it's probably ready now. Kubectl, but I'm calling it kubectl now because I saw some videos. That's how they were instead of kube control, right? So it's kubectl. Get all. Let's see if all the pods are ready. Now let's look at a couple things here. The main thing I'm going to look at is a focus on this entry right here, the service for example dev, the load balancer, right? It still has an internal cluster IP, so you could actually, it's also an internal load balancer on this IP address, right? And it still uses the same DNS internally as we saw with our cluster IP. But in addition, now it has more, and it has a like a URL that we can go to externally, and we should be able to see our internal pods. It'll basically load balance those internal pods. Now, I want to make sure it works first, and then we'll walk through how it actually works. And in particular, this port will be important. This entry, this port entry right here, this 30550. So let me pause the video and just make sure we're settled down before well, actually, I'll just go there right now, actually. So in order to see the status of it, we have to go outside, and I'm going to look at EC2 on Amazon AWS. In particular, I'm going to look at the load balancer entry, right? There's load balancer somewhere here. And you can see the load balancer here. And I'm curious to see, is it ready? So it's not ready yet. So you can see right now, if I go to instances, it still says out of service. So it takes like about 2-3 minutes for this load balancer to settle down. So let me pause the video, and then we'll talk about what's happening. We're back. Okay, so I just waited like another minute or two. And you can see now that if I look at my load balancer, I have a single instance, and it's in service here. Now, just so you know, I normally have two 2 nodes, but because I just want to save money, I've been running only 1 node at a time. So that's why right now you see that there's 2 subnets, but only 1 is in service because I'm only using 1 node. Okay, so the way this works is, if you look carefully at, if you go to instances, so you go to listeners, this line right here tells us a lot about how this load balancer is configured. So this line says it's listening on port 80 on TCP, and it is, and then in terms of the node, it's talking to the node on TCP on a port 30550, which is the same number that you see as this entry here for node port. It says there's a port number right here, this port right here. Okay, and the way this works then is if you go to this website, which is this, let's see if we can make it work here. Let's go to the website. Copy this record. I paste it, and it works, right? So what's happening here is I'm hitting this website. It's hitting a load balancer on port 80, and then it's now going to then redirect your traffic to port 30550 on the node, or if I have more than 1 node, it's a load balance across the nodes on that port. It hits that port, and then the service kicks in. The service, right? It's basically takes the traffic that's on that port and sends it to the service, which then distributes it to the pods, right? So this is essentially how an external load balancer with a service type load balancer works with Kubernetes. That's pretty much it. Now, this was all HTTP, so the question is, how do you make this work HTTPS? So let's take this one out, kube control, or kube cuddle, no, helm, uninstall dev, right? And we're going to look at a different one here while that's uninstalling. There's a load balancer SSL, and it's virtually the same, but there are a couple changes to the load balancer itself. So one is obvious. We are going to now basically tell it to listen on port 443, and then it's going to then redirect the traffic to port 80 on the nodes, right? So this is basically, because now we want the load balancer to be running on port 443. So that's one change. The other change here is up here in the annotations. And this is the part that's very specific to AWS, right? So Google Cloud would be different, right? But in this case, the configuration for to enable SSL is to provide a load balancing SSL cert. And the cert is basically the ARN for the certificate manager cert. So AWS has something called a certificate manager, and that is the certificate manager. And you can see I have a wildcard cert right here for star.todoros.com, and that ARN is basically this ARN right here. So the idea is we supply the load balancer an SSL cert, but at the same time we just make sure to tell, and this might be optional to be honest, but I put it in because it was in the docs. I'm basically saying the backend protocol is HTTP because we're running HTTP on our pods. Okay, so that's it. You basically change the port, supply these annotations, one of which being a certificate, and then you deploy it, and now you've got HTTPS. So let me helm install. Alas, what am I installing? Helm install dev load balancer SSL. Let that deploy, then kube cuddle get all. It's probably all running, but the load balancer, even though I have an external IP here, that listener takes about 2-3 minutes to settle down. So I'm going to pause the video, and then we'll go. Okay, I'm back. It took about 3 or 4 minutes here. What I was looking for was I would go over to here and look for the the instances and make sure they come in service. And you can see now the node is available now, and it's healthy. And the difference here is if you look under listeners, you'll see now that it's listening on port 443 with HTTPS with this certificate. And then it's still, back end is still HTTP on a different port. In this case, this is called the instance port, or the sometimes referred to the node port. And we'll look at this later. But this is basically the port that the service, when it hits that port, it gets to the service. So the way we can check this, the certificate I have here is for a todosrs.com domain name. So in order to make this work smoothly, I actually have to go to DNS. So let me do that real quick. And I'm going to map a new name from that same zone to that load balancer, right? So this is this. And actually, I had created an example before. Let me delete this one real quick. That was from an earlier example. So I'm going to create a new domain name. So create a record set. I'm going to call it example-dev. And it's an alias because it's pointing at a load balancer, which is this one. Create. There it is. So if all goes well, I should be able to go to HTTPS example dev todosrs.com, and there it is. So now I've got my actually, and this threw me off here. This is actually, I was running Apache, and then I see Nginx. This was cached from the earlier example. Let me pause the video and troubleshoot this, because I think I got some caching issues. So I'm back. I had ended up clearing my cache because that was actually, this is actually the website that should be seeing. This is the Apache website. And you can see that it's secure because I got a lock, and it's running example-dev.todosrs.com. So that was really just the exercise of that. So let me get rid of this, and I'll clean up that later. So let's do a helm uninstall dev, and let's see what's next. So we've done a load balancer. We've done load balancer with HTTPS. So we kind of touched upon this already. There's more low-level service option, right, called a node port. It's just setting type node port. And what it does is, instead of going externally and activating the load balancer, it just creates the port on the node, thus the node port, like that port 30,000, whatever it was, and then accepts traffic on that port and then sends it to the service. And the reason why you can do this is, in some circumstances, you may have an external load balancer that's maybe not integrated in with, you can't use a load balancer because your environment, your cloud provider doesn't provide that integration. You can create a node port, and then outside of Kubernetes, you can then manually create a load balancer that then redirects the traffic to the ports. So it's kind of like half of a load balancer. So, and again, the only difference between it, let's look to see what it looks like. The configuration for it is, it's the node port option, and the template here looks, the deployment's the same. So in this case, I'm not using HTTPS. I'm just using port 80, and I give it type node port, and that's basically it. There's no annotations, right? So I'll just quickly run this out here. So let's see. If I do helm install dev node port, because there's no external load balancer, this should be up and running pretty quick. Let's see if I can get this to work. kubectl get all, spelled it. Okay, it's all running. Give me a time to sneeze. Okay, I'm back. You notice that there's no external ID, but there is a node port, and I want to pay attention to that node port because I'm going to use that. So I'm going to copy that port. It's running on port 8. It's HTTP, but it's on port 31924. So now if I go into my AWS, to my EC2 instance, and I look for my node, because this is a port on the node, and this is my node. I want to pick up its public DNS name. Oh, wait. This is a little more tricky. The reason this is tricky is because I actually don't have this node available on a public IP, right? This is only available on a private subnet. So in order to get this to work, I'd have to, well, I could log into the node itself. I could do it that way. Yeah, we'll do it that way. So what I'm going to do is I'm just going to log into the node itself and then just access the service on that port. So that way you can see it's working. So to do that, I need to turn on my Bastion host. Okay, so give me a second. I'm going to fire my Bastion host so we can log in. So bear with me. I'm going to pause the video for a second. Okay, I'm back. So my Bastion host is finally up. So I'm going to log into it. So secure shell -a ec2 user at, this is the public IP address of the Bastion host. Yes. And then I should be able to go, then, see, there's a node running on the same port. I don't think the node's running on the same thing. So I have to figure out the node's private IP. So the node's private IP is this 107 address. Let me pick it up. Copy. Then I do secure shell. I just log into it. Yes. Okay. So I'm on my node. Let's see which curl. Let's see if I have curl on this thing. I do. Okay. So I should be able to do curl and then localhost. But then I have to do the port, which I've already forgotten the port of the load balancer. I could probably get it from here. Oh man. Kube control get all. And then the port's this port right here. This is the node port. And if I copy this, of course it probably won't work, just to irritate me, but and it did work. Okay, so so this again, this port is now opened up, and anything that hits that port will get redirected to the service, which then gets redirected to pods, and then you get your website or your result that you expect. So that's it for node port. All that for node port. Helm uninstall dev. Okay, the last example we're going to do is a quick one. Well, the last type of service is called an external name. It's really kind of a special case because all it really does is provide a CNAME, which is a DNS name, that points to an external name. And what happens then is, basically, as you go to this, whatever name the service's name, it actually gets the IP address of something external from the actual name, a record, and then you go there. So let's look at what it looks like. So it's got a really different characteristic than the other ones we've been looking at. So it doesn't, like, for example, well, anyway, it doesn't, like, it's not backed by a service like the other ones were, or by pods. Okay, so let's do this. Let's look at it first. So this example is the external name, right? And then the template. So it looks a little different. It's basically, it's got metadata, and then it just has a type of external name, and the only thing it has in it in the spec is the external name. And I picked a website called silly.com that does not use HTTPS, because if I use a site that uses HTTPS, this would not work, because my browser I'd be accessing it on a name that was not valid for that certificate. So I'm using, I deliberately went to this website, silly.com, which was HTTP. Okay, so here we are. We have this. So let's deploy this and see what it looks like. Helm. Let's see, this is Helm. Install dev external name. Kubectl. Get all. Right. Okay, so, right. One big difference here is we don't have all the pods, we don't have the deployment, we don't have the replica set, right? We just basically have just this one external name. The external name is a silly.com, and you notice that there's no IP. It's basically just a name. So to validate this, I believe I did run my pod, so I can log into my pod. So let me log into my Ubuntu pod. Kubectl exec example dev interactive bash. Now, which I don't have curl on here, so I have to do apt get update. I should probably pick a container that already has like curl installed. Apt-get install curl. Just trying to be consistent, so I'm sticking with Ubuntu. Okay, so what we're going to do is, let me see if I can do this from memory. Curl, right? The service name was example dev, and then it was the namespace was default. Right. So that actually then returned, if you look carefully at this is actually silly.com, and it's basically, so again, I'm actually accessing it through this CNAME, which maps to silly.com, which then maps to an IP address, and then I actually get the website, right? And again, I'm doing HTTP, not HTTPS, because the name conflict, I'd have a name conflict otherwise. Okay, I think that's all we really want to do on this topic. Okay, oops, probably went too far with that, but okay. Let's see, CD documents, CD, K8ASCKA. Okay, so let's do Helm, uninstall, dev. Okay, the last thing we want to talk about, we saw this earlier. We saw what's called a headless service, and it's kind of another special case. And in this case, I'm just going to recall kind of how we used this previously. So in this case, you really, instead of having a service that's a single IP address, right, you want to basically allow the service. In this case, it's all it's going to do. It's not going to use IP addresses at all. It's going to do some DNS work for us. And the example we have before was when we did the stateless, the stateful set, where we used and we're just going to go back and look at that again now that we've seen services, and we're going to run it just make sure we understand. Well, actually, we'll just look at it actually. So we're going to re-examine the stateful set and see how we used the headless service there and how it worked. Okay, so let me go back to here, and we look back. I believe that was under, I think that was, I can't remember where that's at. I don't know what I saved here. I'll leave that unedited for now. Let me go back and let's see, where were we? We were under the pod networking self-healing application. It was probably in, okay, I'm going to pause the video for a second because I don't remember where this was. And back. Decided to go to the GitHub version of this because I actually put keywords in here, and you can see stateful set is under this article here, and stateful set's right here. So let's look to see what we did there. So in order to get the stateful set to work, we actually had to create a service. In this case, it was headless. And headless is because you set this cluster IP to none. So in this case, the type is a cluster IP, ironically enough, but the cluster IP is set to none. So when this runs, you actually don't get an IP address. All you get is DNS names. And in particular, this was set up so that basically that we use a stateful set, so every pod got their unique name. It was like example dev -01. It was or -0, -1, -2. It was indexed. And then what happened was, because the service existed, it was then mapping, as those pods came up, it was mapping those DNS names to the service. So it was like example1 dot service name dot default dot something. So essentially, again, the whole point of a headless service is to provide some DNS names in very specialized cases, for example, the stateful set. So I think that's all we really need to know about a headless service for now. And I believe that's it for this video.